All right, welcome guys. Today we are going to be looking at the last lesson in this unit. So we've been doing rational expressions and equations, and at the start of this unit we had worked on simplifying expressions, and then in our last lesson we were looking at solving rational equations, and today we're going to be solving rational equations again, but we're going to be doing that with word problems. So as we go through these, we're going to be building our own equations, and once we have those equations, then we're going to solve it and answer the questions. So we're going to jump right into this. Before we get into the first example, what we're going to do is we're going to look at some guidelines for solving the problems. So whenever you get a word problem, the first thing you want to do is read through the problem, figure out what you're actually being asked for. Once you've done that, then you can start to identify your variables. Now, often your last sentence or the last question in the word problem tells you what you're looking for. And whatever you know the least amount about, that's usually your variable. So you're going to introduce a variable. That'll be your unknown quantity. Usually it's whatever they've been asking you for. You'll write your algebraic equation. In this case, because the unit is rational expressions and equations, our equations are going to be rational equations. And then we're going to solve. Once we've solved, then sometimes we have to figure out, does that make sense? Sometimes, just like in some of our other units, we got two answers, but one of them didn't work. For example, with measurement, we can't have negative numbers. And then we will often, with these problems, be using tables because quite frequently, especially with rational equations, tables can be quite helpful. All right, so let's get into our first example here. So this is a revenue problem, and you guys have seen revenue problems before, but this is just slightly different in terms of the wording. So Annika bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560. If she made a profit of $10 on each shirt she sold, determine the number of t-shirts in the case. All right, so I have set up a table again, but you could do this without a table as well. So the first thing we have to do is figure out what information we're given and what we're actually looking for. So first of all, it asks us to determine the number of t-shirts in the case. So this is what we're looking for. Number of t-shirts in the case. That would be the number of t-shirts that we bought. So I'm going to use X, and X is going to represent the number of t-shirts bought or purchased. Now, it's important that you don't just write number of t-shirts, because we have a number of t-shirts that are being bought and a number of t-shirts that are being sold. So it's important that you're clear on what number of t-shirts you're referring to. Now let's go back into the question itself and look at some information that we're given. We're told that we bought a case of t-shirts for $450. Okay. And then it's important to note that she kept 2 t-shirts for herself. So if she bought X t-shirts and she kept 2 for herself, that meant that she sold X minus 2 t-shirts. And then that amount was sold for $560. And then we're told that she made a profit of $10 per t-shirt. So I'll write the information in the chart here. First of all, we know that we bought that case at $450. And that was when we had X t-shirts. So if we spent $450 for X t-shirts, the cost per t-shirt would be $450 over X. Now, we sold that case of t-shirts for $560, but because we kept 2 t-shirts for ourselves, that's X minus 2 t-shirts that we sold. So the cost per t-shirt would be our selling price, $560, divided by the number of t-shirts that we sold, which was X minus 2. Now, our profit or our loss, in this case, they said it was a profit, would be $10. If it was a loss, we would still write the 10, but we would write negative 10. Now, once we have all of the key elements identified in the table, we need to make our equation. Now, in this case, we're looking at our profit. We have a profit of $10. That means the amount that we sold each t-shirt for was more than what we purchased them for. So our selling price minus our purchase price would give us our profit. And again, remember, we're looking at the selling price per t-shirt. The purchase price per t-shirt. So our equation is going to be 560 divided by x minus 2 minus 450 over x equals 10. At this point, that's the new part. That's just creating our equation. From here on, we're going to be going back and doing what we did in our last lesson, solving our rational equation. Now, if you remember from the last lesson, the first thing that we need to do is get rid of our denominator. So we're going to multiply our entire equation by x and x minus 2. Now remember, that's really technically over 1. So as we multiply through, we'll be able to cancel our denominators. So when we multiply through to the first term, we have 560 over x minus 2. Our x minus 2's are going to cancel, and we'll be left with 560x. When we multiply through to the second term, we're going to cancel our x's, and we'll be left with 450 times x minus 2. It's really important that you remember to use those brackets so that we remember to carry the 450 through. And then in our last step, we're going to multiply through to the 10. It is a common mistake to forget to multiply by this term, so make sure you use those arrows to help you out. In this case, we have no denominator, so nothing cancels, so we have 10x times x minus 2. At this point, we're going to expand and simplify. So we have 560x minus 450x plus 900. All right, so remember when we're carrying that through, 450 times x, and we've got negative 450, and then a negative 450 times a negative 2 is a positive 900. And then we have 10x squared minus 20x. The next step would be to move everything to one side and factor. We always want to make sure that our x squared is positive, so in this case, I'm going to move everything to the right. Now, it might help before you do that to simplify on this side. So if you go 560 minus 450, we have 110x plus 900 equals 10x squared minus 20x. Now you might choose to skip this step and just move over the 560 and the 450 at the same time. It's totally up to you. So now we have 10x squared minus 130x minus 900 equals 0. Whenever we're factoring, the first thing that we want to do is pull out a common factor. So we have 10 times x squared minus 13x minus 90 equals 0. And when we divide by 10 on both sides, the 10 will actually disappear, and we'll be left with x squared minus 13x minus 90. So when we're factoring, we're looking for two numbers that multiply to be negative 90 and have a sum or difference of negative 13. And so we want x minus 18 and x plus 5 equals 0. Again, if you were struggling with factoring, you could always use your quadratic formula or plot them on your calculator to find your zeros. At this point, we know that x equals 18 and x equals negative 5. Now, if we were just solving the equation, we would say these are our answers. But we're now working with word problems. So we have to ask ourselves, do these numbers make sense? In this case, our x represents the number of t-shirts being purchased. And so we have to consider our numbers here. We've got 18 and negative 5. Well, I can't buy negative shirts, so my answer is x equals 18. The other thing we always have to consider is our NPVs. So back at the top here, we had an x and we have an x minus 2. That means that based on our NPVs, x cannot be 0 and x cannot be positive 2. And so in this case, those aren't affected. So we have x equals 18. Since the question was asking how many t-shirts that we purchased, then we would say 18 t-shirts. Sometimes what will happen is you'll be asked how many t-shirts were sold. If that was the question, then our answer would be 16 because we kept 2 t-shirts back. All right, let's move on to the next question. These are all just going to be different types of rational expression word problems that you might encounter. So another common question that you might see is one related to proportions. So this question here, it says, how much ink should be added to 36 liters of water to make a solution that is 40% ink? All right, well, if we want to figure out a percentage of ink, this is what we would be doing. So the percentage of ink would be the amount of ink out of the total solution. So just like on a test, if you got 40% on a test, it would be the amount you got correct out of the total possible. Here, if we're looking at the percentage of ink, the amount of ink out of the total solution. All right, so our ink is our unknown. So it's asking us how much ink. So this is our unknown value, so we're going to give that the label of X. Now, we know that there are 36 liters of water in the solution. So that means our total solution is the amount of ink plus the amount of water. So our total solution is X plus 36. So if we want to figure out our percentage of ink, it's going to be X divided by X plus 36. And we're going to express our percent as a decimal, so 0.4. At this point, we can solve by cross-multiplying. You can put your brackets and multiply by X plus 36, but I'm going to put 0.4 over 1, and I'm going to cross-multiply. So that gives me 0.4 times X plus 36 equals X times 1, which is X. Multiplying through, that gives me 0.4x plus 14.4 equals X. We don't have any X squared, so we don't have to worry about factoring, but we can bring our X's over to the other side by subtracting 0.4x. And that gives us 14.4 equals X minus 0.4, which is 0.6x. Divide both sides by 0.6. And X equals 24. Okay, and with units, that would be 24 liters. Now, another way that you could do this question, if you wanted to solve, is instead of writing it as 0.4, you could write 0.4 as a fraction, which is 2 over 5. We'd have 2 over 5 equals X over X plus 36. Same thing, cross multiply. We'd have 2 times X plus 36 equals 5X. That would give me 2X plus 72 equals 5X. 5X minus 2X is 3X, so I'd have 72 equals 3X. And when I divide by 3, X would also be 24. So whether you write your 40% as a decimal or as a fraction, you should still get the same answer. Again, it's important to go back and double check what they're asking. We're being asked how much ink should be added, so we should be adding 24 liters of ink. And you can always go back and double check. 24 plus 36 would give us our total. And if we take that 24 and divide by our total, we should get 40%. All right, so proportion problems are probably one that's quite new for you. These are ones that you see quite commonly in 20-1, so this is one I might suggest putting a star by. Now, we're going to move on to another type of problem. These are what I call our DST problems, or our speed problems. Those of you that are in physics, you probably are familiar with some of these calculations. But again, we're going to be using a chart throughout. And when we are working with anything to do with speed and time, or speed, distance, and time, I will always set up a DST chart. So if you hear me say DST chart, I'm just referring to that table. All right, so let's read these problems. It says, competing in an endurance race, Caden cycled for 120 kilometers, then he swam for 12 kilometers. His average cycling speed was 8 times faster than his average swimming speed. Caden took 9 hours to complete the race, and we're being asked to calculate his average swimming speed. So calculate his average swimming speed, that's our unknown. So typically the one that we're being asked to find is what we're going to make our X. And then we're going to fill in the rest of the chart in relation to that X. Now, before we get into filling the chart, it's important that you understand your formulas. The formula for distance is speed times time. And this is often the one we see here. Speed is distance over time. Again, those of you who are in physics, you're probably thinking about velocity. Velocity is displacement over time. And then time is distance over speed. So these are all the same formula. They've just been rearranged. This is a formula that you need to memorize. It's not one that's given to you on a formula sheet. And so a way that I remember this formula is I think about driving down the highway. If I'm driving down the highway, maybe I'm going 120 kilometers per hour. My speed is 120 kilometers per hour. So 120 kilometers per 1 hour means I'm taking my distance and I'm dividing by my time. So my speed, if it's 120 kilometers per hour, is my distance amount divided by my time amount. All right, so in this case, if we go back to the problem, Caden, Caden is swimming and cycling, and we're trying to figure out his average swimming speed. So his average cycling speed was 8 times faster than his average swimming speed. So if his swimming speed is x, 8 times faster is going to be 8x. Now the next thing we're looking for distances. We have a distance of 120 kilometers, and that was his cycling distance. So he cycled 120 kilometers and he swam 12 kilometers. Once we have that part filled in, remembering that time is distance divided by speed. So our distance is 120 divided by 8x, and then 12 divided by x. So if you set up your chart this way every single time, you won't really have to remember it because you're going to use your table to guide you. Now, we're told in here that it took a total of 9 hours to complete the race. So if the time to cycle is 120 over 8x and the time to swim is 12 over x, the total time will be 9 hours. With these particular questions, you're only going to have really 3 possibilities. Either we're looking at a total time to complete, a difference in time, or we could be told they do something in the same time. Same time would be equal. When it's a difference question, you have to ask yourself which is the bigger amount so you know which one to subtract. All right, so setting up our equation here, we're looking at a total time, so we're going to be adding these. 120 over 8x plus 12 over x equals 9. And again, at this point, I'm getting rid of my denominator, so I'm going to multiply by 8x. Multiplying through, the 8x will disappear. I'll be left with 120. Here, just the x disappears. So 12 times 8 is 96. And when I multiply this through here, nothing cancels because there's no denominator other than 1. And so I have 72x. Simplifying, I have 120 plus 96 is 216, and this equals 72x. So we divide by 72, and then we get x equals 3. Now, again, it's important that you consider your NPVs. You can do that at the start or at the end. In this case, x cannot equal 0, so that's not an issue for this question. And we remember that x represents his swimming speed. So x is going to equal 3. That means he's swimming at 3 kilometers per hour. All right, now sometimes again with these questions, you might not be asked for the swimming speed. You might be asked for the cycling speed, so we could always adjust. Sometimes you're asked for once you've found the x, you might be asked for what his cycling time was or swimming time was. So sometimes, again, there's one extra step that you'll have. Let's take a look at another similar question here. So example number 3, it says, to prevent grounding, a cruise ship anchors 18 meters away from a river port. To transport the passengers to the port, the crew uses smaller boats. The smaller boats travel 12 kilometers downstream in the same time, there's some keywords right there, in the same time it takes to travel 8 kilometers upstream. If the speed of the current is 6 kilometers per hour, determine the speed of the boat in calm water and the time it takes for the small boats to travel upstream from the cruise ship to the port. Now, I can imagine you're probably reading that and your head's already spinning, but we just need to break it down and again use the table to help us. So if you read through that problem, the two things that we're talking about is traveling upstream and downstream. So those are going to be our two cases here. We're traveling upstream and we're traveling downstream. And again, we're setting up our DST chart. So for distance, we're looking for keywords that relate to distance. And so the cruise ship anchors 18 meters away from the river port. And we're talking about travel time. So we're 18 kilometers away. That's our total distance away. And we have the smaller boats traveling 12 kilometers downstream. So this is going to be 12 kilometers. And we have 8 kilometers traveling upstream. So we would have an 8 here. Now, it says that the speed of the current is 6 kilometers per hour. Well, if we're traveling upstream, the current is going to work against us. So it's going to slow us down. So our speed, our x value is going to be our speed. So traveling upstream, the current's working against us. So it'd be x minus 6. When we're traveling downstream, the current is helping us. So our speed would be increased, so x plus 6. And again, time is always going to be distance divided by speed. So 8 divided by x minus 6 and 12 divided by x plus 6. Now, again, those keywords that I mentioned before, in the same time. In the same time means that our time values are going to be equal to each other. So in this case, if you think about it, this 18 kilometers away is just a distractor. It doesn't actually play any role into this question unless they were to ask us how long it takes us to get from the boat to the cruise ship. So if we go back and we look at our question here, we're asked to determine the speed of the boat in calm water. So in other words, we're looking for the value of x. So since these are equal, we're going to have 8 over x minus 6 equal to 12 over x plus 6. And again, this is an equation where I would probably cross multiply. If you prefer just to do method 2 that we talked about the other day, just multiply everything by x minus 6 and x plus 6, that's fine as well. So 8 times x plus 6 equals 12 times x minus 6. Multiply that out and we're going to have 8x plus 48. If it helps, draw your arrows. And 12x minus 72. We'll rearrange so that our x's are on one side and our numbers are on the other. So 48 plus 72 is 120. And 12 minus 8 is 4x. And if we divide by 4, we have x equaling 30. Again, double checking your NPVs. X cannot be plus or minus 6. X represents a speed of 30 kilometers per hour. So x is 30 kilometers per hour. Now, if we go back and just one more time read through that question, it says determine the speed of the boat in calm water and the time it takes for the small boats to travel upstream from the cruise ship to the port. Okay, so our speed is 30 kilometers per hour. If we want to figure out the time it takes to travel upstream, that's 8 divided by x minus 6. So our time is going to be 8 divided by x minus 6, which is 8 divided by 30 minus 6, or 8 over 24. If we put that as a fraction in lowest terms, it's 1/3. Now that's 1/3 of an hour. So 1/3 of an hour is 1/3 of 60 minutes. And if you remember, of in math means multiply. So 1/3 times 60 minutes is 20 minutes. So the answers to our questions, the speed in calm water is 30 kilometers per hour. The time it takes to travel upstream is 20 minutes. All right, so this is another one you probably want to put a star by. These DST problems are, again, a really common example that you see. So we have the proportion problems, we have the DST problems, and then we have work problems. Now with work problems, we're actually trying to figure out how long it takes two people or two machines to work together, or how long it takes them to work individually. So let's jump right into it. With our first example here, the Turtle Dove Chocolate Factory has 2 chocolate machines. Machine A takes T minutes to fill a case with chocolates, and machine B takes T plus 10 minutes to fill a case. Working together, it takes them 15 minutes to fill the cases with chocolates. And so we want to figure out how long each machine takes to fill the case. Now I am using a table here, but quite often, once you see the pattern, you probably don't need to use a table. So let's jump right into it again here. Machine A, the time to fill a case of chocolates, well, we're told that machine A takes T minutes to fill a case with chocolates. So that's going to be time T. And we're also asked how long does it take each machine to fill a case? So in the end, once we have T, we're still going to have to do some more work to get machine B. Now we're told that machine B takes T plus 10 minutes. So that's going to be this one here. And we're told that together they can do the job in 15 minutes. Now, if you remember, when we were working with rational equations, we need to have our equation be a rational equation in order to solve. And so when we're working with work problems, we're actually taking and breaking this down into the fraction of work done in a minute. So if machine A can do the job in T minutes, that means they do 1/10 of the job, one fraction, or they do a fraction of the job in 1 minute. So 1T, or 1 over T. And machine B would do 1 over t plus 10th of the work in 1 minute. And then together, if they can complete the job in 15 minutes, that means in 1 minute they've completed 1/15th of the job. Now from here, we're going to use this information here to solve our equation. We are told that when they're working together, they complete the job in 15 minutes. That means that these two amounts added together will total 1 over 15. So our formula is 1 over t plus 1 over t plus 10 equals 1 over 15. So if you remember that whatever we're working with is always 1 over because we're dealing with the fraction of work done in a minute, you might not need this chart at all. Okay, so just like before, we need to cancel our denominators. In this case, we have 3 different terms, so we have to multiply by all 3 of them, 15t and t plus 10. Same thing when we multiply through, we look at what cancels. So the t's cancel, so we're left with 15 times t plus 10. The next one, the t plus 10's cancel, so we have 15t. And in the third one, just the 15 cancels, so we're left with t and t plus 10. Again, if you want, you can do your NPVs. So t cannot be 0, t cannot be negative 10. So we have 15t plus 150 plus 15t equals t squared plus 10t. Again, we have a t squared. You might want to simplify first. We've got 30t plus 150 equals t squared plus 10t. This is a step you may choose to skip if you want, but ultimately we need to get everything to one side. Because our t squared is positive, I'm going to move everything to the right. So that will give me t squared. 10 minus 30 is negative 20t. Minus 150 equals 0. We're factoring, so we're trying to find two numbers that have a product of 150 and a sum or difference of negative 20. In this case, this particular question does not factor nicely, so you're going to have to use your quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a will give us our t value. And so for here, we're going to have negative 20, so a positive 20, plus or minus the square root of negative 20 squared minus 4 times 1 times negative 150, all divided by 2a, which is 2 times 1. So simplifying down, we have 20 plus or minus the square root of 1,000 divided by 2. Now breaking down our square root of 1,000, we would get 10 root 10. So we have 20 plus or minus 10 root 10 divided by 2. And each of those terms can be divided by 2, so that leaves me with 10 and 5 and 1. So we have 10 plus or minus 5 root 10. And because we're being asked for a specific time, we're not going to end up leaving these exact. We're going to actually have to multiply them out. So we know that our t value is equal to 10 plus 5 root 10, or our t value is 10 minus 5 root 10. And if we put those into our calculator and calculate them out, this one will give us 25.8 minutes or 26 minutes. And this one will give us 35.8, this will give us negative 5.8 minutes. Well, we can't complete it in a negative time, so this answer is actually eliminated, and our answer would be 26 minutes. Now, if we go back to our original question, we're not just being asked how long does it take to fill for machine A to fill the case, we're being asked for both. So machine A is going to be 26 minutes. Machine B is going to be t plus 10, so 26 plus 10, which is 36 minutes. So our final answer would be 26 minutes for machine A and 36 minutes for machine B. All right, we're going to look at one final example. And this again is a work problem. And we're looking at two people mowing lawns. So Hannah mows a lawn in 40 minutes. I'm going to fill this in as we go. Hannah mows the lawn in 40 minutes. When Katie and Hannah work together, they can mow the lawn in 24 minutes. So working together, they can mow the lawn in 24 minutes. The question is, how long would it take Katie to mow the lawn. So our unknown is Katie. Again, we're setting these up as a fraction of a minute. So this becomes 1 over 40. This becomes 1 over x. And this becomes 1 over 24. And again, they're working together, so these two amounts are being added together. So 1 over 40 plus 1 over x equals 1 over 24. We can put a bracket around this and multiply this out. Now our lowest common multiple for 24 and 40 is 960 and x. And remember, if you weren't sure how to do LCM, you can also in your calculator go into your math feature and do LCM and type in 24 and 40 and it'll give you an answer. As well, if you can't figure out the LCM, when in doubt, just multiply 24 times 40 and that number will always work and it will still simplify down nice. So when we multiply this through, we have 24x plus 960 times 1 over x becomes 960 because our x's cancel. And 960 times 1/24 is 40x. Simplifying, 40 minus 24 will be 16. So we have 960 equals 16x. Divide by 16 on both sides. And we have x equals 60 minutes. And so again, we always go back and double check that question. It says, how long would it take Katie to mow the lawn? Well, in this case, it would take 60 minutes. So x is 60 minutes. And again, I do forget as I go sometimes to remember to check for those NPVs, but it is always important to keep that in mind. Generally, with word problems, it doesn't play much of a role. It's not usually an issue, but it doesn't hurt to double check. All right, one quick note I want to make about work problems. If you were to go onto Google or Photomath or other things, you might see that they set up the word problems slightly different. There are actually two completely different ways to solve work problems. You still get to the same answer. They're just approaching it from a different perspective. In my experience, this is the one I found to be the easier of the two, but I just want you to be aware of that in case you were to look in your textbook or online and see that they're setting up their equation different. There are two different ways. This is just the way that I've chosen to show you. So hopefully I've given you guys enough examples. When we get together in class, we'll have an opportunity to go over any questions you have from the lesson and have time to work on your assignment. All right, guys, have a great day and we'll see you soon.